Okay, what we're going to do now is take a look at something we were working on in topic 6.5, and that was to graph the function e to the x power. And you may recall that e is an irrational number that when we approximate it is approximately this, 2.7183. And we want to graph to see what that looks like. Now, as we graph it, I've made a little t-chart down here, and we've put in our standard values for x, 0, 1, -1, 2, -3, and I've even stuck in 3 here. So let's work it out. What we're going to do is put a value for x as an exponent of e and see what we get. Well, if the exponent for e is 0, we know that anything to the 0 power is 1. And if our exponent is 1, e to the first is the approximation of e, which is this. And e to the -1 is the reciprocal of this, so it's 1 over that. And if we put the exponent 2, replacing the x, e squared is approximately 7.4. And if we take its negative value as an exponent, it just becomes the reciprocal. So about 1 over 7.4. And if we cube e, we get approximately 20. Well, that gives us enough points to graph this. So if x is 0, right there, our y is 1. So we put a dot right there. If x is 1, we have e then 2.7184, where we go to 1 and we go up 2 to about right there. And its reciprocal would be about 1/3 approximately, so right about there. And then if we square e, we get about 7.4, so there's 2. 7.4 is right about there. And if we do 3 while we're here, then that's way up there at 20 off our scale. And if we did -2, it's about 1/7. And what's happening now is our points start to become closer and closer to our x-axis, which is actually our horizontal asymptote. Which is, the equation of which is y equals 0. And our asymptote is that point that this line gets closer and closer to, but never reaches. So if we were going to sketch the graph, it would come again very close here, and it starts up like so. And I'll move it to get this one a little bit better here. And then it heads up off to 20 up in this direction here. So this is the curve, the graph, of the function of e to the x power. And we did it by plotting various points and making a graph of them. Now, one of the things we might also do while we're here is, what would the domain of this function be? Well, this continues ever and ever closer to 0, never reaching 0 on our y-axis, but it does go to negative infinity in this direction, and then to positive infinity. These are our x values, the domain. Now our range, as we look at it, it's getting closer and closer to 0, but again, will never reach 0. So it will start from 0, these are our y elements, and go to positive infinity, because that has an arrow at the end of that. Now, another thing I'd like to show you as we do this is what will happen if our graph, or we're asked to graph the function of e to the x power, but also includes a negative 2. Well, we had mentioned in class that when we have a number all by itself out here, a negative 2, then it's sort of like in the form of y equals mx plus b, which is slope-intercept. And the minus 2 is sort of in the place of the b, the y-intercept. So all that would happen to a graph like this, the curve, this part would be the same, but it would drop down, shift downward 2 units. So remember, our asymptote was y equals 0 now, and it does go through 1 here, as we've indicated here. We're now going to shift this down 2 units. So there is shifting it down 1 unit, and now we're shifting it down 2 units. So this is what the graph would look like now, with our new asymptote, our horizontal asymptote, being y equals negative 2, this one here. We've shifted the graph downward. Now, we're going to put it back in its regular form. And now what we're going to do is look at this other function, the function of e. Now, the exponent that we're raising it to is x minus 2. It's included in the exponent, and the parentheses include it. Now, it differs from this one, where the negative 2 is out by itself, in a sense. Here, the negative 2 is part of the exponent. And again, we had mentioned that when you have x as inside of parentheses, it's often in the form of x minus h, where what was the value of that h originally? That is the question. And in order for it to be expressed in this fashion, x minus 2, the h had to have been a positive 2. Because if we take away the parentheses now, it's x minus 2, x minus 2. So a shortcut when we are asked to graph something like this is when we see it's an exponent and it's in a parentheses like this, it is the opposite sign that we're going to move our graph. So where here it looks like a negative 2, we know from this formula that it's actually a positive 2. So there's our original point. We're going to move this over now 2 places to the right. So it would be like a negative 1, and now it's a negative 2. But we've moved it over to a positive 2, and that's what this graph looks like. Now, let's do our domain of these. Notice that when it was this first one where we moved it down to this one here, our domain now still stays from negative infinity. These are our x values to positive infinity. But now the range, because of the way this is set up, has dropped down 2, and it never quite reaches a negative 2. That's our new horizontal asymptote to positive infinity. Now, when we do this other one, again, starting from the original position, that's this one, and we shift it over 2 places, like so. Here, our domain is still negative infinity to positive infinity, and our range stays the same. That is, starting at 0 and going up to positive infinity. So the use of this transparency, I think, was a good little tool, and hopefully this helps you in seeing what goes on when we graph E.